I ended up building a side project for my side project. I had an LLM-based feature that was brutally slow. It was taking like 30 seconds to 1 minute to get responses. Obviously, I had to build another library to parse the incomplete structures from the LLM and speed up the results. Let's jump into what structure generation is, why it was so slow, and how we can stream it. To understand structure generation, we need to understand grammar-constrained decoding. Grammars in this context are a set of rules that can describe every valid order of tokens. For example, subject-verb agreement in English or in JSON that a bracket must terminate the sets of key-value pairs. It is commonly expressed through a meta-syntax like EB and F. Grammar-constrained decoding allows us to filter out all the LLM responses that do not fit into our grammar. This takes the form of masking off the logits of any invalid generated tokens, so we have a guarantee that the output from the LLM will be 100% compliant with our defined grammar. To achieve the constrained decoding, a layer gets added to the transformer before the final softmax layer that will apply the grammar filter to the predicted tokens. Since we modify the transformer architecture, this means that to apply grammar rules, either the LLM provider must implement just constrained decoding, or we'll have to use an open source model with something like Hugging Face. Okay, great. We can get arbitrary structured outputs through grammar now. However, we can only parse the results once we have the full response, which would end up meaning that we'd have to wait a long time to parse that response. So let's take a look at how we can stream this instead. Transformers output tokens one by one, which is conducive to streaming. However, unlike chat responses, if we stream a structured output with something like a JSON structure, we won't have valid structures until the last closing bracket is returned. My structured streaming library in Python addresses this issue. If we're able to stream these structures and parse them without waiting for the full response, we can do a lot of cool things. For example, we can render partial interactive components immediately, so your UI elements can go from loading in 30 seconds to first paint in around 1 second. Since it's so much faster, we can also skip having to put this into something like a queue and just stream this content directly with async. So rich tables, hyperdynamic forms, and other complex components can be good candidates for streaming. I haven't played with this yet, but you could also trigger jobs midstream if you're turning a workflow. So you could have something like cascading workflows with mixed latencies. For example, you could kick off a query as soon as the SQL is generated, while still streaming part of the query explanation back to the user. Another use case that streaming could allow for is some sort of early stopping if a validation check fails, so you wouldn't need to wait until the whole response has been returned to cancel and move on to the next step. Let's look at a quick example of rendering UI elements progressively using this streaming approach. In this example, I'm using FastAPI and HTMX with server-sent events to render the HTML progressively. Since we're using JSON, you could use your framework of choice like React and then just send JSON instead. The three main steps in rendering these components are rendering the placeholder, rendering in the progressive stream, and optionally rendering any additional animations or logic once the full component has been returned. For this example, the objects created from the structure stream may look something like this, where the stream text is added to the appropriate attributes. In the code for this example, there is a new instance of the class that's returned with the new incremental data for each loop. In the future, I may add support for updating the existing class, but it has a minimal impact on the performance. You'll also notice that when creating the data classes or pedantic models, they must have default values, so we know what to return if no value has been returned that matches the existing attributes yet. Other than that, implementation with the library has been as simple as wrapping the stream from your LLM with the parsers from the structured streamer library. Right now, OpenAI is supported, and any open source models through Hugging Face are also supported. It turns out that parsing partially returned responses is actually pretty tricky. I started by writing a simple parser just to handle a couple of cases and quickly realized that would be really annoying to manage and maintain. That led me to check out a finite state machine to handle some of the logic, but it still wasn't really generalizable enough yet, and I knew there must be a better way. The answer was literally looking me in the face the whole time, which was TreeSitter. TreeSitter is designed to handle these incremental parsing cases. It handles things like syntax highlighting in your IDE, so it's really fast compared to anything I could write in Python, because obviously it's written in C and by much smarter people than me. It even has Python bindings, so integrating it into this project was fairly straightforward. Now, even though I'm running the same parsing logic on every loop, after profiling the library, I can see that the tree sitter piece is only taking about half a millisecond to parse in a simple case. Tree sitter also has another awesome feature that I'm taking advantage of, which is queries. It has a built-in query language that supports pattern matching that makes it easy to pull out specific keys and values. Since we'll always know the structures ahead of time, we can dynamically construct queries to pull out what we need without needing any additional complex parsing logic. The last benefit of using tree sitter is that there are already grammars for popular frameworks like JSON. Instead of needing to write my own grammar from scratch, I can just use the tree sitter JSON grammar as a Python package. There could be some cool stuff you could do with defining like a custom grammar instead of relying on JSON, but JSON's right now the most generalizable and supported by kind of the most amount of other libraries. And if you want to check out the library yourself, you can install it directly just from PyPI. I'm still working on building out more features and making the library more robust. Some things I have on my roadmap are supporting data classes, supporting more complex nesting of objects, and re-examining the tree sitter queries to make them simpler. If you're interested in using or helping out with this project, it's MIT licensed, and I'll link the GitHub repo in the description.